Had a Sony VHS Hi-Fi brought in for repair. Guy that owns this one liked it for doing transfer work because it doesn't put up the on-screen graphics when you push play, so that was kind of a feature that he liked. But he also didn't spend a lot of money on this thing. I think he told me he paid like $20 for it, so really there's not any money in this thing. If we can get this thing working with a simple problem, we're going to do it. Otherwise it just may not be repairable. This one's an SLV n750. I take it the n750 means non-serviceable. This is what was on some of the later Sonys. So this was one of the ones that they didn't even service. The running joke was the N meant non-serviceable, and there's probably a lot of truth to that, because this is how Sony went in the later days. Was they didn't provide any warranty service. Customers were told not to return to the store, and if you had a product that wasn't working, you called the 800 number, and if it was still under warranty, they just sent you a new one, and you returned the old one back to them, and I guess they scrapped it. So this one here apparently has a problem. Yeah, it's going to start filming, and an airplane starts flying by. Idiot. So anyway, this one's got a problem, and I haven't even plugged it in yet. I was just told it doesn't work. I don't even think I've ever seen the inside of one of these ones yet. It seems to be held together with a clip, as well as the two screws on the back. There's a clip here that holds the top on. Let's see what type of a treat we're in for. Oh, maybe that's the problem. Cindy and Michael's wedding was in here at some point by Fine Photo and Video from May 1st, 1993. Maybe that's part of the problem. Maybe that's why this thing doesn't work. Let's find out. Talk about cheap mechanisms. Look at this. Oh, what a what a fine piece of junk this thing is. I wonder who made this one for Sony. But this is really a really flimsy looking mechanism. Wow. I guess the first thing I'll try is powering the unit up and see if it does anything. So I've got power to it now, and it's totally dead. Completely no power whatsoever. First thing to do on this one is to determine, is the fuse blown? So power is off. We'll check the fuse and find the fuse is not blown. The unit doesn't have any power, so we have to think, is the switch mode power supply working, or is the power supply dead? So we're going to check for DC voltage here on the rectifier. So I'll turn on the power, and I'll just ground my probe somewhere that should be ground, and check and see that I have no power. Now I don't know whether that is a good source of ground on a chassis like this, but one of these capacitors should be grounded, and as you can see, there's no voltage. Therefore, the switching inverter is not working on this one. It could be, well, we know the fuse isn't blown, but it could be the this is be a MOSFET IC, a drive IC, everything all in one. I just fixed recently a power supply that used one of those units in it. It could very well be that's at fault. First things first, though, we need to check to see whether we've got any power on the AC side. So let's go and look at the AC side of the circuit and see whether we've got any raw AC. So we'll just look, comparing it to the negative terminal on the capacitor here. We'll look and see if there's any voltage on any of these pins, because I should see about 160 or 170 volts on the so we have 163 volts. Therefore, we know that it's got power on the input side, but we've got nothing on the output. It could be that the IC itself is bad, or it could be a filter capacitor here that's bad. More than likely, it's the IC that's gone bad on the primary side, because say we've got voltage, but we've got nothing on the other side. I'll just check some of the other voltages over here and just see whether any of these other diodes have any power on them. And as we can see, there's no DC at all. So now we have to take the board out and start checking. And I'm suspecting it may be this, or it may be one of these resistors has gone open. These are low value resistors that are being used as a fuse in a lot of cases, so it may be one of those that's gone open. But we'll pull the chassis and check it out. And I was hoping for a simple job. And I realize that something like this is really worth fixing. It was brought to me by a guy that, oh, the door is actually there. It's just open because this is jammed mid-cycle. See if I can wind it back. As I was saying, this was brought to me by a customer that I've done some work, a bunch of work for him. His EVS 7000 and his EVS 3000 that I did all the caps on. Same guy that owns it. He does archiving work and uses this machine to play VHS tapes because it doesn't throw the on-screen graphics. He likes it because it doesn't throw the on-screen graphics on. Like a lot of VHS machines, when you start them up, they'll say play, and the word play will come up on the screen for 5 to 10 seconds. Well, when you're using a machine to archive tapes, you don't necessarily want the word play showing up for 10 seconds, or every time the tape speed changes. Like people have a tendency to change tape speeds on their cameras and stuff, or on their recorder. So you don't necessarily want the on-screen graphics coming up all the time, so that's why he likes this machine. And one more screw down here. I'm curious as to what company made this one. I would say Funai, but then it might not be. That's kind of nice. The whole chassis just pops out. That looks like a Funai. At least it's got a metal control cam. I like JVC, which use plastic. Main board should lift out of this unit fairly easily. I think it just clipped in. This one has to come out. This plug at the front lifts out, and the whole board should just lift out. 2004 is when this one was made. April 13th, 2004 is when this board was designed. As you can see, it was designed for Sony. It's a CAN 2 design, but it's a Sony SLV n750. That's the model of it. So it was one that was designed for Sony, or Sony designed it and had someone else build it. It's hard to say. Sony may have very well designed this thing and just had somebody else build it for them. There's a clip here. It's got to come out. There we go. And I'll flip over here. And this should lift the whole board out just like that. We'll see if there's anything that looks out of place on this board. Just say I think it's probably the IC here that's bad. Good chance it's this IC. Now this thing here's probably still got voltage in it. If the oscillator's not running, the capacitor itself won't discharge, and it's still got 5 volts in it, so we're okay. We'll just make sure it's dead. Just going to inspect the board and see if there's any connections that are broken that could be causing this thing to not start up. Okay, these units typically have a fairly high value resistor to start them up. I'm looking at some of the circuitry here. It looks like we got 3 resistors here in series with each other, which end up down here on this IC. So one of these resistors may be open. Let's just take a look and see. We've got, oops, not if I'm in the right mode here. Ohms mode. 47 ohm. 47 ohm. 730K. What is that resistor? That is this one right down here. Just looking at this one, what is this value? It's yellow, or sorry, it's violet, green, yellow. So 750K. And this one is measuring, yeah, 730K. So yeah, this resistor is okay. That one's okay. What about this one over here? 47K. It looks like that's okay as well. This one here is 2 megs. That one might be a little bit high. This one here that I'm measuring, okay. Brown, black, green. Anyone? Anyone? Bueller? Bueller? Of course, Ferris Bueller would know the answer to that because he was a genius. He didn't need to go to school, remember? But if we remember our color code charts, black, brown, red, orange, yellow, green, blue, violet, gray, and white. And of course, the easiest way to remember that is the phrase. And there's 2 variations of this phrase, and I'm going to say the politically correct one because the other one is definitely not politically correct, and I don't want to stir up any controversy. But it's, think of the phrase, bad boys race our young girls, but violet generally wins. And there are other variations of that phrase, which is a little more racy, but we'll leave that one for another day. So, our first color band being brown is 1. And our second color band here being black is 0. And our third color band is green, which is 5, which means you multiply it times, what is it, 10,000? 100,000. 100,000. 5 zeros. So 10 with 5 zeros is 1,000,000. So this is a 1 mega ohm resistor. And as you saw when I measured it here, well, it's measuring a lot higher than 1 mega ohm. It's measuring, now my 3 mega ohms, 3.4 mega ohms. So let's pull this resistor and see whether it's open, because that certainly could be a problem, and especially if it's the start resistor that provides the bias to start the oscillator up. It's I think it's this one here. It's getting to be that kind of time of year. I hear the bike starting up. I hear my bike calling me from the other garage right now. saying, when are you going to get me on the road? I want to go for a ride. Couple more weeks. Couple more weeks and I'll be flying down the highway. Okay, the reason I'm pulling the resistor is because when you get into these high value resistors, sometimes other things in the circuit can skew your readings. But in this case, it's 1 meg, so the resistor is actually okay. I was getting a skewed reading just due to other components in the circuit. So that resistor is okay. What about this other one here? That one is 460, 460K? 0.460K. Yeah, that's right, 460 ohms. My meter's saying 0.460K. But that's 460 ohms, and it's actually a 470 ohm. It's a yellow, violet, brown, so 470 ohm resistor. So that one's okay. So I'm just going to put this other one back in. It's probably the chip that's bad, unfortunately. I'll try to reflow this IC first, and we'll try powering this thing up and see if I get any type of waveforms off of it. I mean, it sure looks like the IC is what's causing the problem on this one, but I'll reflow it just to make sure that we haven't got a bad connection on here. They don't look to be too bad, but sometimes they can be deceiving, especially with this low or there's no lead solder. See, I don't know that I've got one of these ICs, and I'm certainly not going to order one in for what this, because I'm not going to make any money on this thing, you know. There's no money in VCR repair. This is kind of just for a fun project, and if I can get it going, great. If I can't, then I'm not going to go any further, just because the guy that owns it, he won't spend any money on it. You can buy these things for like 20 bucks at the Value Village, so it's not worth spending any money on. That other machine that I had that had the shorted filter cap on, I think I got 20 bucks for that to fix that machine. So it's like that's basically where we're standing with VCRs, is that there's no money at all in repairing them, and it's more of just a fun project to see whether it can be made to work. And if I've got parts, great. If I can salvage a part of an old power supply, I know where one of these ICs is. It's in that cable box that I just put back together last week. But it's going to stay there. I don't think I've got another switch power supply that uses it. A lot of the other ones I have, they don't use this type of IC. They use a transistor. And I'll do the transformer windings here too. But basically, this whole entire circuit is all based on one IC that has all the drive circuitry and everything built in, and if you give it its required voltage, startup voltage, bias voltage, it's going to start oscillating and start running. So there's not a heck of a lot that can really go wrong with this other than the IC itself. We'll test it, we'll see if it fires up, and I'll check it with the scope. We'll see if we get any waveforms off of it. Something like this, we have to ground it obviously to the hot ground, and I'll clip onto the various leads here to see whether there's any waveforms. If it doesn't start up, just gotta make sure this one's not shorting. I'll check the secondary diodes to make sure none of them are shorted. Okay, so let's just try powering this thing up. Plug it back in, and I'll plug it into the dim bulb tester, and we'll try powering it up and just see whether I get anything happening. I'm going on the dim bulb tester so that if I short something, it won't blow the fuse or anything. It'll just turn the light on bright. But first, we'll power this thing up and just see whether it does anything, whether I get any lights or anything out of it. Nothing on the display. Nothing there at all. We'll look at the meter here. And my voltage is here. 167 volts there. I got 166 on the transformer. So we should have oscillation. This is the supply. This is the one going to the IC. We should have oscillation on this one. Let's get the scope out and we'll see whether there's anything running there at all. Any attempt to try and start. Okay, scope is on. Nope, no attempt at all for any type of oscillation, at least from the through the IC. So we're going to discharge this cap, as it's got to have some juice on it now. Bang. Now it's dead. I know I just upset somebody by doing that, but I don't give a crap. I shorted the cap out. Deal with it. Nice scope probe. I gotta get new probes. Cheap. This is my DSO scope. Digital scope junk. This should have a bias voltage applied. I'm just looking to see where it goes. It goes through that 1 meg resistor and then down here, and it comes up here on, goes through this resistor as well, but it should show up on pin number 1. So we should have a bias voltage on pin 1. We can test this one with the meter. So let's grab a ground clip here. We'll check for bias voltage on the actual chip. Okay, so we got 160 volts here. We don't anymore because I've shut off the power, but we got 160 volts here. This is going to the drain, and 160 volts comes up here. 166 volts. This is a bleeder resistor. This is that 1 meg resistor, and it's down at 0. So something's pulling that down really low. It could be the IC itself. It's pulling that down. This one goes through the optocoupler. This is for the feedback circuit here. The optocoupler. And it also is supplied over through here. Goes through this bleeder resistor network over here. Ends up over here. 2.9 volts. This is probably the start voltage here. This one comes down through this resistor here, drops to 0.03 because it's going to IC, pin number 3 of the IC, and I think the IC is shorted. Because the IC, everything is at 0. Like everything's at 0 except for the drain. Right? The drain is at full potential 166. These two are connected together, which is the same as this. That goes to the transformer, and then the power comes in right here. This is the input from the main filter. As you can see, there's the main filter to go straight down here to there. Goes through the transformer primary, which then goes through the IC, and the IC is the switch, which is switching it on and off. And I think the IC itself is shorted. And that's what the problem with this one is. I say I don't know that I've got one. I'm pretty sure I probably don't have one of these ICs. I got a lot of switching power supplies, but they use transistor. They don't use a MOSFET and drive IC all in one. And I did have one last week that I pulled out of this little power supply here that I used to fix that little cable box, which is the same IC. But I'm not pulling it out of the cable box to fix this because that little off-air antenna, or the off-air receiver, because I intend to try and use that thing again at some point when I can locate a remote for it or program up my harmony or whatever I'm going to do with it. This is what I mean when I open up a lot of these power supplies like this one. You'll see that this one here It uses a transistor, right? There's no IC in this one, so that's what I mean. A lot of these switching power supplies, crack them open thinking you're going to get lucky. This is one that had a European plug, so I didn't really care about it. But they don't work because most of the designs are based on the a transistor. Not a lot of them use an IC like this one. Another one here. This is a pretty lightweight one. Let's see if I can crack this one open. There we go. Are we gonna get lucky? Cool. And interesting. Look at that. They just snap the whatever base on they want for the prongs. Cool. What do we have in this one? Ooh, I think we might get lucky. I think we might get lucky on this one. This is a K0267. I know a lot of these are interchangeable with each other. What is this one? Okay, I got the replacement IC here. I don't know if it's the same. It's a different number of IC. This one here says I mean, a lot of these are interchangeable with each other, but this one here says it's an STRA 6351, and it's an A6351 on the chip itself. This one's a different IC, and if I look at the circuitry that it came out of, on this one here we can distinctly see that the pins are different. Pin number 1 is over here on this side, right? So if the IC went in like that, so pin number 1 is over here. Pin numbers 7 and 8 are bridged together, but also 5 and 6 are bridged together, right? So 1, 2, 3, and 4 are the input pins, but 5 and 6 are bridged together, 7 and 8 are bridged together, and if I look at this one, they're not. Only 7 and 8, I think, are bridged on this one. Let's see here. 7 and 8 are bridged together, but these ones are not. Right, so 5 and 6 not bridged. 7 and 8 are internally bridged, because that's your drain. So I don't know whether this is just not connected on this other one, or whether it's a different IC. I have a sneaking suspicion it's a different IC, but I don't know if it works anyway, because this power supply it came out of was dead, so this IC might not even be any good to begin with. Let's put it on the meter here. I don't want to risk blowing something else up, right, if the IC itself is dead. So let's just see if there's any shorts on this thing. That looks pretty bad. This IC itself might be toast. I'm starting to think it is toast, because the switch power supply it came out of, that little wall wart, was dead. But I don't know whether it was dead because of bad caps, or whether, well, yeah, this IC is shot. Dead short. Right? Source to drain is dead short. Because that's drain there. Source is one of the pins on the other side. There we go. Right? Source to drain is dead short. So this one's not going to work anyway, so oh well. As I say, when I was looking at the power supply it came out of, I realized that these were bridged together, so I thought maybe we had a different IC, but not only do we have a different IC, I think this one here I say is shot. So that one's not going to work. So I think at this point of the game, this VCR is just going to be put back together and sent back to the guy that owns it, and tell him he should go buy himself another $20 VCR at Value Village, because that's what these things go for. It's like 20 bucks. I kid you not. VHS VCRs are, the secondhand stores here are dirt cheap. They're not worth anything. So I think on this case, this one is beyond repair. If I had an IC to put in there, I'm pretty confident that would fix it. That IC. In fact, I'm probably 99% sure that if I had an IC, I could pop it in there and this thing would work. But I don't have one that's compatible, and I know someone's going to look it up and they're going to say, oh, you can get that part for $2 and some odd cents. Yeah, great, great. Even if I could get the part for $2 and some odd cents, delivered to my door for $2 and some odd cents, this machine can be had for cheap. How cheap, you ask? Well, I'll show you. $24.99. Okay? This is what I picked up at Value Village for $24.99. DVD recorder. VHS recorder. I rest my case. Not worth fixing. Now, for you guys that want to stick around while I put this together, I'll tell you a bedtime story. Because it's asked of me many times and I've really never gotten into it. But people have asked me, when I got into the business, or when I got into the repair work, or how old was I when I started learning about this stuff? And I'll tell you, because I've never really, I don't think I've ever really, I've told you guys that I worked for Sony, and I worked at a Sony self-servicing warranty depot for a long time, 20 years. And I worked for actual Sony of Canada there for a while. But if we go back further than that, this is going back to the 1960s. Must be a trick to putting the scene together. There we go. Go back to the 1960s. There was, in the town that I live in and grew up in, I grew up in the same neighborhood where I still live right now. In fact, very close. I was only, my parents' house was only a couple blocks from where I ended up buying a place. And we had 1963, a TV shop opened up out here called Imperial Electric. And I actually got to know the owner of it when I was a kid, but not that well. But there was one other guy that worked in the neighborhood, and he was very close to where I am right now. In fact, that house right there, almost directly across the street from where I live, used to be the original TV repairman's house. In fact, this garage area, well, it's not a garage, but it used to be a garage. That used to be his workshop, right there. This is early 1960s. He was the original TV repairman out in my area. His name was Al Mallet. Now, the reason I was filming it through my door like that, through the glass, was because my neighbor's actually out talking to somebody in their front yard. Not practicing social distancing, I might add. But didn't want to be too obvious. I was taking a picture of their place. But anyway, yeah, he was the original tech, TV repairman. And back in those days, the TV repairman actually came to your house and did the work in your house. This thing's frustrating me going back together. There it is. So they came to your house. He would come to your house and do the work, change tubes, whatever. And if he had to repair it, if he couldn't fix it in the house, they'd actually pull the chassis back in those days. All the TVs had a removable chassis, and you could just pop the chassis out, take the chassis back to the shop, and work on it. And they had a test jig, which was basically just a picture tube with a yoke plug sticking out and the CRT connector, like on a cable. And there was adapter cords that would go to the various chassis, but they were all pretty much interchangeable back then. So what they would do is, if the TV couldn't be fixed in the house, he'd pull the chassis and he'd bring it back and work on it in his house. And the old chap, he was an old British guy. He learned his trade during the war in the RAF. So after the war, he immigrated to Canada and set up shop in that house that I just showed you, which is across the street from where I live. Now, I didn't live here then, but he was a friend of the family. He was a very good friend of my parents, and he was very good friends with my grandmother. And, they used to, always be visiting. They'd be over visiting or so forth. So because he was a friend of the family, I could, when I was young, and I'm talking, 6 or 7 or 8 years old, I think I was somewhere in there, probably about 6 or 7, be like 1968, 69, somewhere in there. maybe 1970, I'd go over to his house, and he'd let me watch him work when he was working. I'd be riding my bike around the neighborhood, and if I saw his truck there in the summer, it's always in the summer because in the winter his doors were closed, but in the summer, you know, he'd be working with his garage door open. And I'd see him working away, and I'd go in and talk to him. And he'd let me come into the shop and kind of show me different things and teach me about what capacitors did and what what resistors did and all the different electronic circuits. I don't need to plug all this stuff in because it's not going back together to work. Anyway, oops, forgot to put that little circuit board in. I guess I better do that. Anyway. He was a tube jockey. You know, he retired when transistors started to come out, and I guess it was about 1965. Another shop opened up, a shop called Jack's TV, of all the names. Guy's name was Jack, obviously, and he set up shop as well. So then there was Al's home shop, and there was Imperial Electric, and there was Jack's radio. Anyway, old Al, he basically retired when color TV started to become popular, and tube or solid state stuff started to become popular. He didn't learn transistors, and he was old at the time, so he just retired and closed down his business. And basically, that little house at one time, he got into satellite TV in a big way. He had 4 6 to 10 foot dishes on the roof. I remember going by his place, and he'd have like 12 TVs in his garage, and he'd have all these different broadcasts on from all over the place. He'd be watching newscasts and stuff. He had cable TV with a bunch of TVs hooked up to cable, and he had these satellite receivers, and he could pick up all this stuff from all over the place. And he was, after he retired, that became his hobby, was just searching out satellite signals and record. He got into VCRs in a big way because he'd sit and record all kinds of stuff off of satellite. But anyway, to say, when I was young, I used to go over and hang out at his place, and he would kind of show me the ropes, teach me what a capacitor, resistor was, how vacuum tubes worked, and the very first thing I ever fixed was when I was going over to his house. It was an old AA5 AM radio, All American 5, and he made me fix it. I'd go over there, and tinker around with it, and he would kind of show me what some of the different things did, and basically got me to fix this radio. And then I got to keep it. It was one of those little Bakelite radios. First time I ever got damn near electrocuted was by one of those things, and it was totally by accident, because hey, I was only probably, I don't know, at that point I was probably maybe 8 or 9, because this has been a few years, maybe 8 years old. I'm thinking maybe 8. I'd had this radio for a while. They gave me this radio that I fixed by putting new tubes in it, some new capacitors, or condensers as they called them back then. And I used to listen to this radio at night. I had this big long wire antenna that was like 100 feet long hooked up to it. And anyway, I remember the Bakelite, it had Bakelite knobs for the tuner and the volume. And one of the knobs was broken. I remember I was leaning on a windowsill because I had it up on the windowsill, my bedroom window, because the reception was better. And I had the long wire antenna going through the window and hooked up. I just basically had it wrapped around the like there was the antenna coil in the back, right? They had a wrapped wire around the back on the paper back to it. I took this long wire antenna and I just kind of wrapped it around the coil and used it for induction to pick up signals. And anyway, I remember I got this one hell of a shock because my arm was leaning on the metal frame to the window. The window was open because the wire was coming in through the window, right? So I was kind of hanging up there. And my arm was sitting on the window frame, and I touched the volume control, which was just a bare shaft, because the plastic knob on the front was broken, and it was in the day of the AA5 chassis with a non-polarized electrical cord, which meant, depending on what way you plugged it in, there was either neutral on the metal knob or the metal shaft, or it was 120 volts. And wouldn't you know it, the time that I plugged it in with the hot side on the chassis, and that woke me up. It knocked me down off the chair I think I was standing on, and then I got mad and threw the radio down, and the bakelite cabinet all smashed because I got a shock from this thing, and I threw it out, and that was the end of that radio. Anyway, that was my first experience with electronics, was hanging out with the neighbor that used to live across the street from where I live now. And he's been dead for years. I forget what year he died. Probably, I think it was in the 1990 maybe, in the late 80s into the 90s. It's been a while. He was old. But anyway, yeah, that's how I got started. And then after, just kind of tinkering around with that, when I was in high school, I built some different projects, including a black and white video camera, a security camera from scratch, from some plans that I got from a company in California called ATV Research. And they were catering to the amateur TV community that was experimenting on the UHF for broadcasting pictures. And they had a camera. It wasn't so much a camera kit. Well, I guess it was. It was a kit because it came with all the parts. But nothing came partially assembled or anything. It came with a bag of resistors, capacitors, transistors. The circuit board wasn't finished. It came with a layout of a circuit board, but I had to etch it and everything, and I had to drill it and make the case and wind the focus and the yoke coil. The yoke coil was wound onto a toilet paper roll. That's what was used to form the yoke coil for the little Vidicon tube, and it was all held in place with epoxy, and it actually worked. And I wish I still had it, but silly me, I used it what it was intended for, as a security camera, and someone decided one night that they wanted it more than me and took it from the side of the house. They actually climbed up on the fence and took it. Anyway, this thing's back together. As to say, it's not worth fixing. We'll continue this story of my my entry into the electronic repair on a future video. Thanks for watching.